Yeah, I think now it's working, and you can double check through the link.
Yes, I agree that it's working. So thank you very much uh, for making this change, Yitun.
Yeah, no problems. So maybe you should add some extra instructions into the doc
Yeah, we will do
settings.
that.
Yeah,
Yes,
thank you,
definitely.
thank you.
Thank you. And Somesh, just to let you know that the live streaming is currently recording,
Oh,
and
no problem.
anyway, we will start in 4 minutes. And
Oh,
it just we wanted to make sure that the live streaming is working properly.
okay. So, Faraz, how big is ISTA now, attendee wise?
Yeah, we can wait maybe a minute or two more and
Oh,
then
no
start.
problem. Yeah, this is informal, so that's okay.
Oh, I think Somesh, you may be currently muted.
Am I?
I can actually hear.
Or maybe my headphones. Let me double check.
Yeah,
because
I'm not. I have video and audio both on.
Let me see because okay, yeah, I can hear you now. Yeah, it was because I switched from a different device, so just had to reconnect. Okay, I think we can start. Thanks everyone for joining. This is the last talk for the summer school today. It's my great pleasure to introduce Somesh Jha, who's gonna give the talk about security and his work on security. Somesh graduated with a bachelor degree from Indian Institute of Technology, New Delhi, and then he obtained his PhD at CMU, I believe back in 1996. And then he joined the University of Wisconsin-Madison around 2000, where he is now a full professor. So his work has been mostly related to formal methods in security and formal methods for security and related topics like intrusion detection, which I believe he will cover probably today, at least part of that work. He published over 150 papers on these and related topics, and he's a fellow both of ACM and IEEE. So it's my great pleasure, and I'm looking forward to hear what he's going to tell us today.
Just 1 second, let me get the slide. I can share my screen, right?
Yes, you should be able now to share your screen.
Okay, just 1 second. Share screen. Can you guys see this?
Perfect, yes.
Okay, play from start. Okay, can you guys, so can you guys see the slides?
Yes, we can see full screen.
Okay, great. So I sort of Milos talked about sort of me working mostly in security and formal methods. This talk is going to be slightly different. So thanks for I hope it's not a surprise to Milos and Surfraz, but I've been mostly working in this field now for the few years, trustworthy learning. And what I want to do is sort of look at this field from maybe an ISSTA point of view, okay? And hopefully there'll be people in the audience who can jump on some of the problems that I'll mention. So this is kind of what I've been doing for the last few years. And actually, I'm reminded of this quote by Richard Hamming, which basically said that if you don't change your area every 7 to 8 years, you get intellectually stale. So I follow that quite a bit. I started in model checking, then moved to security, and then sort of now I'm moving into this area, and I actually hang out mostly at ICML and those places now. So in any case, so this is kind of what I'm going to do. I wanted to say that my DNA in some way is, just 1 second, my DNA is still, my research DNA comes from more my sort of PhD my PhD was sort of pure model checking, and that's me. I don't look like that anymore. That's me after I defended at CMU. And I used to regularly publish in places like CAB, FSC, and also ISSTA. So, a lot of the stuff that I still do, even though it might be in a different field, comes from that research DNA. And I just, it's a pleasure to be sort of giving this talk, because it's almost like when I go to those conferences now, CAB, FSC, ISSTA, it's like coming back home for me. But now, mostly I publish in security and ML venues. Okay, can I? Okay. So what is the purpose of this talk? So the purpose of this talk is not a survey. I don't want to survey trustworthy machine learning. There are enough out there. I just want to give enough background and maybe call out some problems that might be useful, sort of, so that somebody from the ISSTA community can kind of jump on these problems and sort of think about it, right? Because in some sense, what I feel is that in machine learning, we have a certain perspective, and a perspective from testing and other communities kind of missing in this field. If you wanted to get a very ML-centric tutorial on robustness and trustworthiness, here is a tutorial that was from last year's ICML. I consider privacy and fairness also part of this, but we are not going to focus on that too much this time. Okay, so whenever people say trustworthy machine learning, they actually cover robustness, privacy, fairness is all part of trustworthiness. By the way, Milos, what are we doing with questions? What do you want?
Yeah, so basically it's silly on you if you wanna also answer things on the way, but the way it's gonna work is that people are gonna post questions on Slack and I'm gonna ask you at the end, unless you prefer to hear
Yeah,
questions.
I prefer questions as I go on. So
okay, then people should just probably unmute themselves and just ask question when they have.
Yeah, I think this way, because it's slightly more sort of a summer school feel if it is more interactive, right? So,
sounds good.
So yeah, I think if you guys, if you want to sort of ask a question, please do so. Okay, I don't want to kind of belabor this point, but essentially machine learning, as you know, is everywhere now. Healthcare, energy, transportation, education. I don't want to belabor this. Hopefully, I don't have to convince you of this. But there is the thing. So 2013 was kind of a turning point for machine learning when they started in some tasks like recognizing objects, faces, breaking captchas. They started really almost reaching human level performance, or sometimes actually beating them. Okay, so just keep this in mind. And this is more for my sort of family. There are a lot of doctors in my family, and all of them think that even though I'm a doctor, I'm the wrong type of doctor. So they think I'm still even after so many years, I think they still think I'm a failure because I'm not a medical doctor. So this is for them. There's sort of ML is also beating there was a lot of hype in 2017, and a lot of the standard medical tasks like reading radiology readings and all that, ML was also beating doctors. So take that, my family, okay? Now, machine learning is also being deployed in adversarial settings like autonomous robots, autonomous driving, YouTube filtering, and so on. And sort of ML is also being used in a lot of cyber physical systems, right? Sort of autonomous driving, robotics, drones, and so on and so forth. Okay, so let's get back to this, right? So I think I am old enough where I remember there was kind of 80s and 90s was a little bit revolution for software, because folks realized, hey, I can do stuff in software that is much more agile than in hardware. And a lot of things that used to be done more in hardware started moving to software, right? Like control software for robots or shuttles and so on. And then, that was, people were happy about that. And then the phase 2, people started thinking about, okay, what about security? What about critical bugs and failures? Can I trust my software in critical settings? And to me, that was kind of the golden age for formal methods, if you will, and testing and so on, analysis, software analysis, and so forth. It was basically addressing these kind of questions, and a lot of new, nice techniques sort of came out of that, okay? So this is kind of the life cycle that all new things that are disruptive come through. So now imagine that if you are writing good software, imagine that we don't have well-established testing and analysis techniques. We don't have a good way to find security vulnerabilities like what we have now, static analysis, fuzzing, and so on. We don't have a good debugger for software modules. And in my view, this is where we are right now. In ML, a lot of some of the work touches on all these three, but this is where we are at right now. So we are in phase 1 of ML in this. And what is the big problem? If you have taken ever an ML class, right? So what happens is if you have ever taken undergrad ML or graduate ML, they have a data generating distribution, and the training and test distribution are the same, right? Generally, what you say is you draw some samples from a training distribution, you minimize the loss function, and then you sort of test, but you imagine that they are from the same distribution. The problem is this IID assumption true? The answer is actually no. So adversaries don't care what your assumption is, so they will break this assumption. There is also something called covariate shift, which is non-adversarial, where test and training distributions can be very different. So imagine you train your object detector in Seattle and you are testing it in Austin, right? Where it's hopefully more sunny. And so, things can break. And so there are a lot of techniques that are to deal with that. So all I want to say is that this IID assumption is invalid in a lot of ways. So for example, this is a stop sign from, it's a physical stop sign from a CVVR paper from some folks at Michigan, where they were able to emulate like a graffiti on a stop sign. And most object detectors think this is a speed limit sign, okay? And you can imagine, if you think that road signs are drawn from a certain distribution, what is the probability that you will be able to draw this monstrosity, right? Good. Now, I want to also say that adversarial learning is not new. If you look at, I've seen papers sort of from 2004 on sort of, on spam detection, but because of all the hype in sort of machine learning, it has basically, become more important now. And a lot of new theoretical techniques are being developed here. Okay, so let's take sort of a view of a software pipeline for machine learning, right? So you have a training set, you use your favorite learning algorithm, you get some learned parameters, and then you give it test input saying, hey, is this a cat or a dog? And you get test output, right? So this is your software pipeline. And in some sense, there are vulnerabilities and brittleness in each step of this software pipeline, okay? Now, one thing I need to do is I need to kind of just give you enough ML basics so that I can talk about some of this stuff. And so what we're going to assume is that we have a sample space. X, think all images, cats and dogs. Y is a set of labels. D is a distribution that corresponds to the sample space. H is a hypothesis space. So think about it as weights of a neural network machine and network. And loss is basically saying, hey, if it's saying that if you have a misprediction, how much am I penalizing, right? And generally in machine learning, what you do is you want to minimize the expectation where something is drawn from a distribution of the loss plus some regularizer, okay? And the second line is just sort of an empirical version of that. And generally what you do is you draw a sample from this distribution and you will sort of, this is a simple stochastic gradient descent. You can do batch gradient descent and all that sort of stuff. But essentially what you do is you update the weights of your machine learning model. But notice here which will be very important. You essentially take a step in the negative direction of the gradient of the loss function. Okay, that's all you need to know. This is all machine learning will do. Once you have trained your weight, you will have a classifier that says, okay, this is a cat, this is a dog. That's all we need to know. Okay, training time attacks. So what happens in a training time attack is, by the way, people in Austin like Milos won't understand this, but we do get snow in Madison. So this basically says this is the year and how many ice days were in each year. And you fix a regression model, and this shows you that the lines are going down, which can be some evidence of global warming, right? So imagine that you're a climate denier. You kind of poison the data so that the line now goes up. So this is like a classic poisoning attack. Okay. So in a very formal setting, this is, you have a data set S. Alice gives the data set to Bob. Bob can poison few data sets so that the goal is to maximize the error for Alice and get close to learning from. And the goal of Alice is that you want to learn as close from the clean data as possible. Okay. By the way, what I'll be doing is flashing sort of these representative papers as I go along. Now notice that a lot of this work is a very sort of a statistical perspective. And from a ISSTA or some a software engineering perspective, people have not looked at things like this. So this would be a very interesting problem, at least for me, if somebody from this community starts looking at it. So all these techniques are in what I would say in a very clean setting. And now, but what you can do is if you talk to sort of practitioners, they will use something like ML flow or something to manage their ML pipeline. The idea will be, can you put these almost as regression tests in your ML flow pipeline and say, okay, hey, here, your data set seems to have some crazy data in them. Try to clean them this way. So I think a lot of what I feel is missing in this community is, you kind of develop a technique, you write your NIPS paper, your ICML paper, and you give your talk, and then you move on. What they don't do, and this is where we really need the software engineering community to come in and sort of really help us, is that how does this fit into the software pipeline? Okay. How can this help somebody who's using the software pipeline? So I think there is a lot of synergy here going back and forth. Okay, the second one is the following.
So maybe a
yes.
quick question. So how do they evaluate? I mean, compare maybe to our community, to software engineering community. Mm-hmm. What are the steps in the evaluation that they take, and how maybe robust?
Well, I mean, the evaluation will be, you will pick your favorite data set like CFAR or whatever, right? You will poison the data set, then you will use your technique to learn over the poison data set and just say that the accuracy didn't drop too much, right? Okay. But so for example, just to give you an example, I was talking to a sort of an industrial group here in Madison, actually, and they were more interested in that, okay, these techniques are fine, but I'm using ML flow is a software, is a pipeline for doing ML. How will this fit into my ML flow pipeline? Where, for example, if I have some data set which I suspect I'm getting from a third party, might not be clean or might be poisoned or whatever, how do I fit it into my software pipeline, right? I mean, so the thing is, a lot of these people are, all they're interested in is that they will write their NIPS paper and more focus on the technique, and they don't look at the full ML software pipeline and say, okay, how can this actually be incorporated into a full software ML software stack? Does that make sense, Milos?
Yes, I see. Basically, the integration in the actual tool chain and potentially the cost of integrating, writing the stuff, running the stuff, and
yes,
etc.
is completely missing. Okay. In general, what I find from this community is that a full system software stack perspective is missing. Okay.
Cool.
Great.
Thanks.
Yeah, as I said, unmute yourself. I would rather have it, not go through all my slides and have questions rather than that. So that is, I think Miloš asked a great question. And I think this is where the interaction should be, is that if you've, what I hope is you will take this talk and you say, okay, let me dive deep into this and bring more a software engineering perspective to it. Okay, so model extraction. So you are a software company. You have a great data set. So for example, about diabetes or something, what you do is you train a model, you put it up on the cloud, and you charge people for per query. Okay, so for example, 23andMe and other places have a lot of data. What they can do is they can sort of take a service, put it out there, and then people can upload their genetic data, other things, and say, okay, hey, how likely I'm supposed to get diabetes or whatever, right? So this is called ML as a service. And it is becoming quite popular, and a lot of big players like Amazon, Microsoft, and Google are kind of betting on this, as sort of a lot of people will do that. Okay, so but here is a problem. People have they have shown that by using reasonable number of queries, I can actually steal your model. Okay, so I can build an approximate model which will be pretty close to the model in the cloud, but I can just, by very clever querying, can build an approximation of it. Okay, so they call these model stealing attacks. This it was originally, I think the term came from a Usenix security paper in 2016. You should also look at our upcoming paper by I think Varun Chandrasekharan, the lead student, is going to give the talk on connecting model stealing to active learning. So I think the idea here is that essentially, if you can do model stealing, then it essentially makes all this business model of ML as a service just extremely useless, right? I mean, why will I pay you if I can steal your model? And actually, if you look at our paper with the current pricing models, it takes us like $200 or $300 to steal a very complex model. So then why should I, after that, why should I pay you, right? Now, so that I think, I don't know. So one thing could be is, can this be addressed where essentially what I'm thinking from a more ISSTA community is you take my ML as a service model and you use these model theft techniques and you give me some idea that how brittle it is so that I can take some defense, or maybe what I can do is also use it to set my query pricing. So that would be a great sort of a problem for some of the ISSTA guys to look at. Can you kind of test these using some of the techniques and sort of give me some, idea that, hey, maybe you should be setting your query price like this. Maybe you should using these defense techniques and so on and so forth.
Somesh, I have one question quickly here. Is there also like bound on the number of queries that attacker can try in this setting?
At least not right now. If you look at Google pricing stuff, they just have per price. Yes, you could probably do that, right? You do a sort of a limit the queries, right? But those things won't work, right? I will just open a new user persona, right? Why can't I? So what you're saying is I'll limit like, okay, this sort of user queries to assert, and what I can do is I can have 10 people open accounts. So those kind of simple defenses I don't think will work.
Okay. I might more like interesting, like for example, password attacks and so on in software. You, I mean, algorithmically you can recover the password, but you need many queries. I was wondering if similar analogy.
Yeah, so password is slightly different, right? If you look at the password crackers and so on, that's a slightly different model because essentially, but here the model is different. The thing is, these might be actually legitimate users of your service, like you, Surfraz and all that. But what I'm saying is just rate limiting won't matter because what I can do is I can open 30, I don't know, I pay 40 people in India who open personas and we have a coordinated attack that we run.
That makes sense.
Right. So by the way, this kind of, these kind of the rate limiting sort of stuff password is slightly different setting because there what you're saying is that let's say some things get exfiltrated, a password database gets exfiltrated. Can I run these batch crackers to crack your password much quicker? And there, I think that's why they do salting and so I think the setting is slightly different here. Did I answer your question?
Yeah, I think that makes sense. So I just wondered what are the differences and similarities. That makes sense.
Yeah, I think here because the thing is, it's not like an illegitimate user. I'm making legitimate queries to you, right? I'm not making illegitimate queries. I pay your service. I actually am paying the money. I'm not sort of stealing. I'm just like I do my querying so in a smart way that I'm able to steal your model.
Yeah. So the problem here is that you cannot distinguish between like adversarial queries and the like normal queries that you expect. Basically.
Yeah, so that is a very interesting question. So you're saying that there might be sort of an anomaly detection thing here, where the query profile of these model theft is very different than normal profile. That might be an interesting defense. There is a paper by Nicholas Carlini and Dave Wagner that try to do this in a slightly different setting. That to me is slightly more promising. But I haven't seen anybody who has taken this to, I would say, reality in some way. So essentially would be, or have a provable defense.
Makes sense.
But that's an interesting idea.
Thank you.
Yep. By the way, there is a lot of work which I call it ML for bad. ML for bad meaning I'm not doing any attacks on ML, but I just use ML to generate fake content. So mostly using things like generative models to generate photographs. You must have seen this, taking a speech by Obama and then altering it saying that he's a Muslim or something like that, right? So those, I don't know what you can do about. I don't know. That's using ML, but using it for bad things. So I personally didn't know how to do that, but I call them fake news attacks. Okay. There is also test time attacks where you don't tamper with the model as it is training, but you try to sort of fool it using some test time inputs. So let me give you an example. So this is from Goodfellow, which says adversarial examples are inputs to machine learning models that an attacker has intentionally designed to cause the model to make mistake. Okay, not these might not occur in nature. So for example, this picture of an orange in a whatever the net might appear in nature and might fool machine learning model, but this is not what we're saying. We're saying intentionally the design. So for example, this was the first attack that came out, I think 2013, which took a panda and added some noise to it. This is not random noise, this is well-crafted noise. And the top model, machine learning model there said it was a gibbon. And obviously it's not a gibbon. So this is what I mean. And this noise is well-crafted. So like that stop sign, right? What I do is I put stickers at the right place so that it becomes sort of a, sort of a speed limit sign. And now notice that these things were not, if you look at the earlier papers, they were not called really attacks. They were almost like curious properties of, if you look at Shedesi's paper, it didn't even call it an attack. He called it like intriguing properties of neural networks or something like that. Okay, so the idea here is, I don't know. I think the thing is, this is what is called a test time attack. Because test time, because you're taking something at test time and screwing a little bit up, and it becomes a given. For example, this is from the same paper, school bus becomes an ostrich, and this is my favorite one. I love guacamole. So this is a tabby cat becoming a guacamole. And all the adversarial examples have been done beyond deep learning for logistic regression, also beyond computer vision. People had started looking at malware and software and so on. Okay. So I think formalizing it a bit, essentially the way I formally look at this is, you have an oracle, and this is the oracle from The Matrix, my favorite movie, which basically says, one, if examples X and X prime are perceived the same. So think about O as a binary oracle. Think about that as a human being, okay? The human being says X and X prime are the same. Now, what targeted local robustness says, that if T is a target, let's say, let's take an example of X as a speed limit sign. X prime is slightly perturbed speed limit sign, but the human says it's still speed limit. Then suddenly the classifier should not say it is a different target T. So this is what is called targeted local robustness. Global robustness says that basically the human being or this oracle thinks that these two X and X prime are the same, then the classifier should also say that they're the same. So the way I think about from more a model checking and software engineering perspective is that targeted adversarial examples are essentially counter examples to this predicate. That's it. Okay, so think about this as a specification, and adversarial examples are just counter examples to that. And global robustness, as I said, says that if the oracle says that X and X prime are the same, then Fx is equal to Fx prime. Essentially, we want this to be the classifier to be robust on all inputs, which is a very, very tough thing to get. So what you say is that the expectation where it will be non-robust is small. Okay, and again, that's what I want to say. Adversarial examples are counter examples to this predicate. Now, the problem is that we don't know how human perception works, correct? Am I wrong? Anybody who wants to challenge me on that? At least I have sent mail to a lot of my vision colleagues, and I don't think fully we understand how human perception works. So we don't know what that oracle is. So what researchers do is almost take a shortcut and essentially are approximating that oracle by L infinity norm, L1 norm, LP norm. So as long as X and X prime are within a certain norm, they say that the oracle says one, right? So this is a big problem in the community. So the folks have started actually criticizing in this field, saying, oh, these norms don't really mean anything in real world. So let me give you an example. So I'm sure I was looking through the ISSTA program, and there were a lot of ML for code type papers. And there were a lot of ML type code type papers in PLDI. In fact, I would guess that 30–40% of PLDI was something, every paper had something to do with ML. So Milos, Sarfraz, how many papers were in ISSTA on ML that touched on ML?
I think percentage-wise, it sounds similar to PLDI.
Okay, so yeah, so imagine now you have, so for example, there is these ML papers that do code recommendation, right? Sort of saying, oh, maybe this function looks similar to this. I don't know, maybe Vechev's group or some other people have also done it. I think Tao Shi might have also done some work like that. In my view, those will be very trivial to break using that, right? If I take a code base, I can very quickly maybe change some basic blocks and variables and so on to actually fool your machine learning model, okay? But think about it. If I take two basic blocks and just switch it, what is the L infinity, L1, LP norm of that attack is huge. That's in the feature space, it's probably changing the features quite a bit. So the problem with this community is that L infinity, L1, LP, these norms are not good for our community, okay? They are not good for software engineering or programming languages. It's just, to me, it doesn't make any sense. Now, having said that, there are people who have started looking at this, and this would be something that I hope that even the ISSTA ICSI community starts looking at, when they use machine learning, that they also evaluate robustness. I mean, to me, it is like follows, right? If you have a software engineering paper that finds, that does security defense, there are a lot of them. Will it ever get into a conference if you have no threat analysis? I would venture to guess no. Correct? And it's the same thing. We are right now with ML to code. If you look at PLDI, ISSTA, ICSI, I'm on the Popl PC. And actually, I was surprised. Popl, I thought, was more like a programming languages, sort of like this big, Sebastian of programming languages. They also had a lot of ML for code papers. And so, to me, we need to get to the point where we can talk about robustness of these things. Otherwise, to me, I don't know, it's like having a paper in software engineering / security where you have no threat analysis. So this is a very important point. Any questions on this? In fact, next ISSTA, you guys should put it in the call for papers. Hey, if you don't have any robust analysis, we will desk reject it. What do you think, Sarfraz? Or Milos? I think that's...
Yeah, I think that's an interesting idea. We're gonna suggest your name as a PC chair for next year. So
you can call me the desk reject chair. No, but I really think it is. So, for example, let me give you another thing. Like in machine learning, people worry a lot about domain adaptation, right? So, for example, if I talk to you about, if I train my object detector in Berkeley, I'm just picking Berkeley because I think it is very sunny there, and I take my model, it should suddenly not break completely in Seattle, where it is totally cloudy, right? So that's so the vision people really worry a lot about domain adaptation. In this community, in software engineering and PL, imagine Imagine what you do is you train your code model on some GitHub repo, which a lot of people are doing. And now I use it in my organization, and my code base looks very different. I bet you, and I'm giving you $100 challenge. Okay, I'm a very very poor professor, and both my kids went to private colleges, so I cannot afford more than $100. But if you take your standard paper in ISSTA, which is trained on, let's say, some GitHub code base, and you use a different style of code base, I bet you $100 to $1,000, or no, 100 to 1. It's the bad odds that all these things will break, because in some sense, a lot of these community, like in the software engineering PL community, they don't even understand the term domain adaptation. Okay, so one thing that we need to do is that there has to be a lot more crosstalk between the machine learning community and the PL community, which is happening, but I think the bandwidth of that communication is low. So for example, this is a great problem for somebody listening. Look at domain adaptation at ML for code. I think it's a challenging problem. Any questions on that before I move? By the way, I like to talk, so I think then you guys need to keep me animated by asking questions. Okay, I don't need to get into that. There are various threat models like white box, black box, gray box. White box means you know the complete classifier. Black box knows you only know data from X. I'm not going to get into that. And I'm just going to flash through these slides because, so there are a lot of attacks. FGSM was the first one. Then there's a PGD attack. One of my first papers with Nicholas was the first one that was targeted. I'm not going to get into that. I'm just flashing that then so that you guys can see it. There are so many other attacks. I don't want to just get into it. Okay. There are also a lot of black box attacks where you only get a black box model. You just get the labels. You don't get the actual classifier. And I'm not going to get into that too much. But here is a very interesting idea. And I think there might be something here. In some sense, a lot of these black box attacks you can think about them as a very interesting black box learner, where you're learning by looking at, you have only black box access to the software. I personally feel that it might be useful for testing software and maybe ML-based software. So for example, imagine bug finding in software engineering and verification where you don't have access to software, okay? You only have access to black box software. Can some of the techniques used in the adversarial attack community be useful in the software engineering community? Because think about it this way, what these things give you is they're giving you essentially an oracle to estimate some gradient information in a black box way. Can that be somehow used in testing or verification where you only have black box access to software? Imagine sort of legacy software. By the way, the ISSTA people will find this very interesting. So my wife works for DWD. It's a Department of Workforce Development, where she has just switched jobs, but before that, they handle all these paycheck protection programs and so on. And they accidentally gave more money than people were requiring. And I think the problem was that a lot of their software was still in COBOL. Okay, I don't know how many, the crowd here is pretty young. So I don't know how many people even know COBOL, but a lot of their software was in COBOL. So the idea is that can some of these techniques from this community be used to test legacy software? Okay, so I think the synergy goes both ways. I think I think this would be very interesting. I'm not going to talk about defense, but all I'm going to say is that defense has been kind of elusive. It has been a rat race. For example, there was a paper in ICML 2018 that got the Best Paper Award that broke 7 out of the 8 defenses that were published in the previous conference 6 months before. Okay, so I don't know. I won't sort of talk about that too much. So that's why there is a lot of thing in the community to go towards certified defenses, where along with the prediction that, hey, this is a cat, you also give us a robustness certificate saying that, yeah, if you change this image but in an epsilon ball, the prediction doesn't change. Okay, so here they do use some abstract interpretation and so on and so forth. By the way, I haven't looked at the program, and maybe Milos, you can tell me how many papers in ISSTA still do some standard decision procedures, model checking type stuff?
This year, I think there were only a few.
Okay. It used to be probably much higher when at least I published in these things. But there is a lot of the certified robustness one. Essentially, there's a lot of interest going on in this, and there are multiple papers in PLDI, CAV on verifying neural networks. Okay, and essentially the way you can think about it is essentially a decision procedure for this second line. It's trying to say, hey, is my prediction robust in an epsilon ball? It is using techniques from SMT solvers, abstract interpretation, to do that. Okay, so the first paper I think which kind of did that was a CAB 17 paper by Kotz et al. And this was based on using SMT solvers. And every year, it's getting better and better. So for example, 2017 was the CAB paper. And if you look at, there's an ICML paper that already, at least I have not verified this claim. It's from, by students of Inderjit Dhillon and Luca Daniel from MIT. They claim that they were 10,000 times faster than that. So there is it's getting better and better, these decision procedures. Any questions on that? So I would claim that these things will keep getting better, but still they are at a stage right now where they cannot do very sort of large neural networks. They can do small things. They can't they're not scalable yet. Now there is one technique that has
hello, I have a question.
Okay, hi Numair.
Hi. So there has been a lot of work on testing and verifying machine learning algorithms, neural networks, or what have you. But so, for example, if you are able to come up with a technique which is saying that your network is not fair, or there's a problem in your network, right? How do you fix that problem? Like, do you change the data, or how do you fix this?
Okay, so this is, I think you didn't peek at my slides, did you?
No, I didn't.
I'm just kidding. Okay, so I will tell you, this is the hugest problem in this community. Okay, so you have extremely sort of hit this nail right on the head. So let me rephrase your question, Numair. So there are a lot of these attacks. You can think about these attacks as finding counterexamples or bugs, right? I already said that. There are also certain things for fairness, like flip test and so on, which basically tell you that, hey, this prediction was not fair. Okay? So there are a lot of these things. So in some sense, think about these as various test cases. But what Numair is asking is very interesting. is that can you take these test cases and give me some insight, how can I fix them?
Yes.
Okay. So for example, I sort of run all this poisoning and all this stuff, very fancy, and it comes back and says, well, guess what? You guys are susceptible to poisoning. Okay, what do I do with that information?
Yes.
Do I call my mother? I talk to my dad? What the heck do I do? So I think what is missing in this whole community is taking this and then distilling it into some model insight or insight into your software ML pipeline, saying, hey, maybe you should be collecting more data like this. Or maybe you should be doing this. Maybe you should be using this architecture or that architecture. This is completely missing from the community. Okay. So what I want is, how many of you have heard of these tools like AutoML style tools? Have you?
Yeah, I've heard.
Do you guys know what I'm talking about? AutoML and fast AI and all these.
Like hyperparameter optimization.
Yeah. Basically, no, it's more than that. They also actually suggest some architectures. So what they do is it's basically a very glorified grid search over your architecture and that space to basically say, hey, your data looks like this. Like you have tabular data, you have image data. Well, maybe you should be using this architecture with these parameters. Okay. But what is missing, so which is, I mean, I don't want to call it software engineering, but it is like a little bit like software engineering, right? It's telling you what you should be focusing on. That is completely missing. That doesn't look at robustness, fairness, and so on. So what I want is, I want AutoML style tools that can run these tests and so on and so forth, but then give me some actionable insight. Numer, did I answer your question?
Yes. Thank you.
So I would, if that was a great question, I would get on it. Your next
Right.
submission, you already have your next ISSTA submission. Yeah, that is completely missing. So this happens quite a bit. I was talking to sort of a company that does ML for malware detection, and we have some paper which looks at robustness for that. So then we can say, oh, we can tell you when you're not robust. Well, that's not what they want. They want to say, okay, what the heck do I do with this? Do I add another layer? I use adversarial training. What do I do? And adversarial training in that domain didn't fix it actually. So I don't know what it is. So
It's
by
like,
the way, the
it's like program repair for ML, right? That's what you want to do.
No, actually, it's more than program repair. It's more like
equivalent
software cycle repair. It's not enough to just repair the program. Sometimes it might be, in case of fairness, it might be saying that, hey, your data set is very unbalanced. You can't do anything about it. So collect some more data like this. Well, that's not program.
So you have to look at the whole pipeline. Like
exactly.
Where can you make a fix?
Exactly. So I mean, so let me tell you my dream problem. There is this thing called ML Flow, which is a open source thing. The Databricks has put a lot of money into that. Okay, it's essentially a sort of a software ML pipeline, but it is almost focused on training and test metrics and so on and so forth, right? Accuracy and awk and rock and so on and so forth. Can we bring fairness, robustness, all that stuff into ML Flow? So that would be a great problem in this community. Okay. So I'm actually running out of time a little bit. So I'm just going to say that one of the things that this adversarial attacks, this adversarial training does is basically you train your model on worst case attacks. I'm not going to get too much into that. And theoretical explanations, again, we know very little about why these things happen. There's a lot of work on that, but the jury is still out. So one thing before I end, it's at 3:55. I want to say that this is where um, a lot of work from the ISSTA community will also be needed. Um, so there is a lot of explainability techniques, okay, in the literature. So here are some of the explainability techniques: IG, DeepShap, C-explain, Lime, and they have started gaining a lot of traction, okay? So for example, this is a thing that I just got from integrated gradients. Integrated gradients is mostly done on right now on images. You can look at the explanation, which is basically a heat map of how important a pixel is. And at least you can tell that, hey, this model looks like it is learning the shape, right? So on the left is the actual image. On the right is the integrated gradient, which basically assigns a weight to each pixel, which says how important this pixel is to that prediction. So you can see that the shape of the image comes up. You see that? At least I think it is coming. The problem is these attributions are also very fragile. Okay, so there was a paper from some Stanford folks that took sort of this is a windflower or something, which the model still says it's windflower, but the attribution completely changes. So from the software community, this would be like you're predicting bugs, okay, but your prediction completely changes as the software changes a little bit, which is not great, right? And so we have some work on making these attributions more robust to these small changes. But here also, what I feel is that, think about this, goes back to Numair's question, is how do I take these explainability techniques and go to a higher level? So for example, and the second problem is that these explainability techniques are very good for images. They have not been developed so much for ML for code. So for example, imagine I'm doing some function name prediction or code completion using ML, and it doesn't work. Can I take these explainability techniques and say, oh, this is not working because here is a problematic construct here because of this construct. So unfortunately, this is the story of ML right now. A lot of the work is focused on NLP and images and so on, and they have not been transitioned for ML for software too much. It's always running 5-6 steps behind, okay? So somebody can correct me, but I haven't seen great adoption of these explainability techniques in ML for code. That's a great problem. Next is ISSTA submission for you guys. I'm running out of time, so I'm just basically going to say that Sanjit and I have been pushing this quite a bit, and Varun is in the call. Varun is helping us with that. Is that in general, there is a lot of this adversarial robustness stuff works in a vacuum. You look at a single image detector, this and that. ML algorithms don't sit in a vacuum. So for example, in an Uber control loop, it's doing something in a full control loop. Can we basically lift the discourse of these ML algorithms and try to find examples that can fool the entire control loop? And on that, I said, basically, I will end. And by the way, I'll make these slides available because there's a lot more there that I didn't cover because I just like to talk. So I just kept talking. So here's, I'm just kind of telling you how much we have done. And I just hope with this talk, if anything you can take that first, there are a lot of interesting problems from the ML, trustworthy ML, but on the software side. So hopefully we'll start seeing more ISSTA submissions there. And the second is a lot of these techniques like robustness, explainability, and so on have not made over to PLDI POP. There's some, PLDI, POPL, ISSTA, ICSI. I feel like they're always running 2 cycles behind. Okay. So for example, one problem, what Numair just said, right? What do we do with, what do we do with these? Can we give high-level insights? Can we have explainability for ML for code? So that would be great, I think. And on that, I will end and I'll stop share. This is Saturday afternoon, so that's a little bit more time.
Yeah, thanks a lot. Thanks, Somesh. So now, thanks for the great talk, and especially for connecting this very nicely, to ISSTA, and suggesting so many interesting topics. I'm sure that people will benefit greatly from this. We had several questions on the way, but we can take a couple of more minutes in case anyone has any question.
Any question? Yeah, I think, as I said, this is my big thing for a lot of this stuff is that I feel like a lot of the software, ML plus software communities is sort of few phases late. So for example, explainability techniques have not still moved to software for ML. So it will be great to sort of look into that. Okay.
So any
great.
questions?
If there are no questions.
Yeah, I have one that I wanted to ask when you were talking about the adaptation, domain adaptation. I heard a bit, read just like a paper on that, so I'm definitely not an expert. But I'm curious, when you see, for example, a software engineering paper, so how much do you, in what cases do you expect certain things to generalize or to hold, or to be applicable to something else? Versus how much you think that what people present should simply address that particular problem for that particular type of software, right?
No. So what I'm worried about is the following. So I think what I'm more worried about is the following. So let's say I write a great paper by getting some code from GitHub, okay? And I'm getting very good results on some software task like function name prediction or code completion, whatever, right? Two things. First of all, there is drift in the data set as well. If you look at GitHub from 5 years back and from 5 years now, it's probably the model won't work. I'm pretty sure if you take a PLDI paper from 4 years back and look at even the GitHub software now, the accuracy is going to drop like crazy. I bet you money on that. The second is you also don't want, let's say I'm an organization and I say, oh, I want to use malicious software that was doing that. I'm pretty sure it won't work. Because the way I write software or the style of things is very different. Okay. So the domain adaptation techniques from vision have not been looked at in this. You don't want a paper from ISSTA this year that works nothing in 2 years, is giving you crap results. Does that make sense?
Yes.
Because it is looking at features in software, right? And if that completely changes, then, so I'll give you a idea from a different domain. I have been working with a colleague who's in the wireless computing space, where they're using a lot of malware and where they're using a lot of machine learning. And we tweaked the data set a little bit, and the accuracy dropped to random guessing, basically.
I see what you mean.
So you don't want that. And I bet, and the problem is that the vision community has already seen this. So there are a lot of techniques for domain adaptation, which you're not very susceptible to things like covariate shift and so on. But they have not made over to software yet. Now, I think what I also want to say is that when you look at these techniques in the software domain, I have a feeling that they will actually sort of also maybe open up new things, right? It's not going to be applicable right out of the box.
Sure. Yeah, probably. As you said, like, adaptation and kind of taking into account certain features.
Yes. Yes.
Cool. Any final question at this point?
Yeah.
Okay, no one is raising hand. Thanks a lot, Somesh. We very much appreciate your time, especially that, as you said, it's Saturday.
Okay, no problem.
I very much enjoyed the talk. I'm sure that kind of people will kind of watch it.
Okay. Thank you so much.
Okay, thanks a lot.
Bye.
Bye.